Hello, good morning students. See, welcome back to our e-learning session. See, in our last session, that is in first lecture of chapter number 5, skewness. Here we see that the symmetric frequency distribution, right? The definition and the example of symmetric frequency distribution, and we also know about the skew frequency distribution and the types of skew frequency distribution also. That is, there are two types of skew frequency distribution, and here first type that we already see that positive skewness is we already see. I hope you all complete the example given into the textbook for the symmetric frequency distribution that we already did in the on the board, and the positive skewness, that is the example of positive skewness also we discussed about that. I told you that you have to write down that in your example book. Now the second is negative skewness. What is the negative skewness? See, I told you that here whenever the skewness, whatever the skewness is, means what? Whenever the symmetric distribution is not, then it means it's a skew frequency distribution. What is the negative? Negative in that sense, here, see, this is the diagram, a curve of negative skewness, right? Here I am reading that if the left tile of the frequency curve of the frequency of the distribution is more elongated, then it is called a negatively skewed distribution. This one, right? Such a population is said to possesses a negative skewness. See, both the populations, that means here negative as well as positive, had different curves. Symmetric distribution has a bell-shaped curve, then positive skewness has a right hand side elongated, the curve is right hand side elongated, and in the negative skewness the curve is left hand side elongated. Okay, now we will study the negative skewness obtaining the frequency curve, this one, and the central tendency measure of the following frequency distribution. Again you have to do this sum in your example book, as well as I told you that here in the positive skewness you have to do the sum. Again here in the negative skewness, the price of an item and the number of customer is given 6, 7, 8, 9, 10. That is, the price is given up to 20 and the number of customer is 1, 2, 3, 4, 5, 8, then 10. The highest frequency is after the middle, that means after the 50%, the highest frequency is there, that means at 17 and 7, 4, 1. Okay, so here the curve is like this. On the next page, see the curve just like this. Okay, 1, 6 on the 6, then 1, 7, 2, 8, 3, 9, 4, and so on. So the highest frequency on 17 is 10. At the top here, the highest frequency is 17, and it is fall immediately 7, 4, and 1. Okay, so here the left side curve is more elongated in negative skewness. You can see that the left tail of the frequency curve is elongated. Less observations are distributed to the right observations. X is equal to 17. Yes, highest frequency at which the mode is what? Here highest frequency observation, and here in this case the highest frequency observation is 17 because the highest frequency is 10 and the respective observation is 17. That's why you can say highest frequency observation X is equal to 17 corresponding to maximum frequency 10, whereas more observations are distributed to its left and their frequencies are decreases gradually. Okay, so here now we find out the mean, median, and mode and quartiles and deciles from these sum. Okay, so I hope you all complete that. So please do that right now. I am giving you here 5 minutes for that. It is a revision for you. Chapter number 3rd, revision, mean, median, mode as well as quartiles, right? So here 6, 7, 8, 9, 10, 11, 10, sorry. Then 15, 17, 18, 19 and 20. That is your X. Customers 1, 2, 3, 4, 5, 6, 5, 8, 10, 7, 4 and 1. That is your frequency. To find out mean, you have to find out fx, that is multiplication of f and x, sigma fx. Then find out x bar. Then find out cumulative frequency for median as well as quartile. And find out median and quartile on the basis of that. And also the mode is equal to highest frequency observation. That is, we already know that here the highest frequency is 17 and the corresponding observation is 10. So your mode of this, 10 is the highest frequency and the corresponding observation is 17. That's why your mode is equal to 17. Okay. So do this sum first. Make it fast. Here, first of all, fx, multiplication, total of fx is 642. N is equal to 45. So your x bar is equal to sigma fx upon n. 642 upon 45. That is 14.27. That is your x bar. Now median. Find out that n plus 1 by 2 the observation, m is equal to 45 plus 1, that is 46. That is 23rd observation. See in the cumulative frequency column where 23rd observation is lies. In the cumulative frequency 23 exactly is there. So 15 is the corresponding observation. So m is equal to here again 15 rupees. Median is equal to 15 rupees. Then mode, highest frequency observation. Highest frequency observation, that is 17. Highest frequency is 10. That's why you can say you have to write in full-fledged. Okay, I am just explaining you here, and this is the revision for you. That's why you have to do this sum fully in your example book. Okay, this is the mean, median and mode. Now the quartile, first quartile, Q1, n plus 1 by 4th observation. (45) plus 1 by 4. So 11.50th observation. And 11.50, see in the cumulative frequency. 11.5, see in the cumulative frequency. It lies on 15. 10 or 15, between 10 or 15. That's why the corresponding observation is 10. So MQ1 is equal to 10 rupees. Then find out Q3. 3 into n plus 1 by 4th observation. Please do that. 3 into 45 plus 1 by 4th observation. So 3 into 11.5. So 34.5th observation or 34.50 observation. See in the C left column. After 33 and before 40, so it lies between 33 to 40. So the corresponding observation is 18. So Q3 is equal to 18 rupees. Now see here, value of X bar less than value of M less than value of mode. See here, 14.27 less than 15 less than 17. And then here, this is the first. Now the second. Q3 minus M minus Q1. Here Q3 is equal to what? 18. 18 minus M, 15. 18 minus 15. And here 15 minus 10. So here you can say less than also. Q3 minus M less than M minus Q1. So here the difference is 3 and here the difference is 5. So second characteristics of negative skewness. This is the first characteristics and this is the second characteristics of skewness. Okay, or negative skewness. Okay, see here from the frequency curve showing X bar, that is mean, median and mode, and the values of quartile, it is clear that X bar 14.27, median 15, mode 17. That's why X bar less than median less than mode. This is the first. Second, the left tail of the frequency curve is more elevated, yes, and the Q1 minus M, 18 minus Q3 minus M, sorry, that is 18 minus 15, that is 3, and M minus Q1, 15 minus 10, that is 5. So again we can say Q3 minus M less than M minus Q1. Okay, the following characteristics are generally seen in the negative skewed frequency distribution. First, mean, median and mode are in increasing order. See the difference between positive and negative skewness. That is the most important. Positive skewness and it is a negative. What is the first part? X bar greater than M greater than MO. Here in the positive skewness, mean, median and mode are in a decreasing order, and in the negative skewness, mean, median and mode are in a increasing order. This is the difference between the positive and negative skewness. First, okay, and in the symmetric distribution, what is that? X bar is equal to M is equal to MO. That means here mean, median and mode all are equal in symmetric distribution. In positive skewness, mean, median and mode are in a increasing order, sorry, in a decreasing order, or in a negative skewness, mean, median and mode are in a increasing order. That's why you can say here X bar greater than M greater than MO. Here X bar less than M less than MO. And the second, again same, Q3 minus M minus Q1, here less than, here again the greater than. That is the difference between quartile, third quartile to median and median to first quartile is here highest or here the lowest. Okay, so the distance between the third quartile Q3 and the median is less than the distance between median and the first quartile. Here it is less than, here it is greater than. Okay. And the last point, third point, the left tail of the frequency curve of this distribution is more elongated in this, and here the right tail of the curve is more elongated. In the positive skewness, right tail; in the negative skewness, left tail. Okay. So please remember this, because the characteristics of positive skewness as well as the negative skewness is also asked in your examination. Okay. So this is your theory part. See, practically we did that, but the theory must be asked as well as here. Types of skewness, positive, negative, you have to detail that by doing the curve, that is a graph. Okay. In the normal page, not in a graph page. So here the positive and negative skewness, the types of skewness is over. Now note, we find more variation in the observations to the left of the mode is negatively skewed distribution. Many cases related to business and finance having negatively skewed frequency distribution. For example, negatively skewed frequency curve is found in the frequency distribution of price of a certain item, number of investors, etc. This is the example is given in day-to-day business. More negative frequency distribution, negatively skewed frequency distribution is given into the day-to-day business. Okay, so that is the note. And now the main concept, that is the concept of absolute and relative measures of skewness. See, in our last chapter, that is in chapter number 4, not in last chapter, but in the chapter number 4, measures of dispersion, we already see that the relative or the absolute measure of R, that is coefficient, and coefficient of mean deviation, coefficient of standard deviation, coefficient of quartile deviation, and coefficient of range. Okay, that is the relative measure of the dispersion. Now the relative measures of skewness we have to see here. See, we can find whether the skewness is the frequency distribution of a population observation is positive or negative by drawing the frequency curve. But the degree of skewness in the distribution cannot be found using the graph. Here we can just say by using this graph or by using the negative or positive skewness, that is both the graph we just see only it is a negatively skewed distribution or it's a positively skewed distribution, but at which point and what measure is given here, that we cannot find out. Okay, so here the absolute value of negativity and absolute value of positivity is not find out by the graph. You have to find out by the absolute value or relative measures. Okay, two types of measures are used for measures skewness. First is absolute measure and the second is relative measure. We have to find out these two types of measure. A measure of skewness which is expressed in the same unit of a population variable is called an absolute measure or skewness. It is denoted by SK. Skewness only, that is called as small k. Okay, and it is called an absolute measure. The absolute measure of skewness is obtained by the difference of averages in Karl Pearson's method and by difference of quartiles in the Bowley's method. Here two statisticians are there. They given their skewness formula, right? First one is the Karl Pearson, that is the very well known statistician. We already see all the formulas of Karl Pearson in chapter number 3, 4, right? And here we use that particular formula, and here skewness new formula is given by the Karl Pearson we have to use, and whatever the new statistician is there, here the name is Bowley. Okay, and it is he is also given a formula for absolute measure of skewness. Okay, so here two methods, that is Karl-Pearson method as well as Bowley's method. These methods cannot be used for the comparing two populations having different units. Compulsory. If you have to find out the measures of one populations, then you can find out only at that time only one unit, because here you cannot measure the different use, or you cannot compare the two different populations having different units. Okay, even when two populations have observations with the same units, it is not advisable to use absolute measure, as the measures of central tendency and the dispersion may differ in the distribution of the population. Here the condition is given, but here whatever, this is the only theory, whatever given, just we have to read that. It is not a compulsory. Here only we have to know that skewness, that is our absolute measure, and the coefficient of skewness, that is our relative measure, we have to find out in this chapter, in these sums. Okay, thus a relative measure is used for the comparative study of two or more populations, which is called coefficient of skewness. The absolute measure of skewness of a population is divided by the appropriate measures of dispersion to obtain a measure of skewness which is free from the units. Always the relative measure is free from unit. In quartile, decile, coefficient of quartile deviation, coefficient of standard deviation, coefficient of mean deviation, always the answer is free of unit. If you find out the quartile deviation, that is the here, at that time you have to apply the unit. But if you are finding out the coefficient of quartile deviation, then it is free from units. So here you can say again, relative measure of skewness is also free from unit. You don't have to write any rupees, kg, all the units after the answer of coefficient of skewness. Okay. The absolute measure of the skewness of population is divided by the appropriate measure of a dispersion to obtain a measure of skewness which is free from the units. In short, now main point, the relative measure of skewness is called coefficient of skewness, and it is denoted by small j. Small j. Skewness is denoted by Sk, that is our absolute measure, and coefficient of skewness, that is our relative measure, and it is denoted by small j. Right? Okay. Now two methods. This is the theory, and theory portion of this chapter is now over. Now we have to concentrate on the practical one. There are two methods. I told you here in the theory portion, there are two statisticians are there, Karl-Pearson and Bowley. First of all, we have to see all the measures of all the formulas of Karl-Pearson, and then we see all the formulas of Bowley. Right? Now, method of determining skewness and the coefficient of skewness. Two methods. One statistician is Karl-Pearson method, and second one is Bowley's method. Now see the formula of Karl-Pearson's skewness and coefficient of skewness. Please write down these all the examples of positive, negative as well as symmetric frequency distribution. Then write down the characteristics of symmetric, positive and negative skewness, and this is the important theory. Please write down these in your example book. Okay. Now see the Karl-Pearson method. The values of the mean, median and mode are not same in the skewed distribution. Yes. And the median is between the mean and mode always. See, in the positive, and in the negative, what is the characteristics? X bar and here x bar. So you can say here mode is always between the median is always between the mean and mode. Hence the difference between the mean and mode is generally used to find out the measures of skewness. Here if we want to find out the skewness, we have to take the difference of mean and mode. Mean and mode, here mean and mode. Okay, so the two ends, we have to find out the difference between two ends. Okay, so here the formula for Karl Pearson. Please write down the heading Karl Pearson method, and the first formula for skewness is equal to, you can write down SK in short form. It is denoted by SK. The difference between the mean and mode is the formula x bar minus MO. The skewness SK is equal to x bar minus MO. The coefficient of skewness J for the unimodal distribution is obtained by the dividing skewness by the standard deviation, that is S. The coefficient of skewness is thus found out by the following formula. Here the second formula, coefficient of skewness, it is denoted by small j, and here this one SK, skewness, is divided by S, that is standard deviation, right? This is the formula for J, or you can say what is the detailed formula of J is equal to x bar minus MO upon S. Here SK is equal to, skewness is equal to x bar minus mode. Coefficient of skewness is equal to skewness divided by standard deviation, or you can say, if you have to find out the directly the coefficient of skewness into the sum, then x bar minus mean minus mode divided by standard deviation is the formula. Here you have to use the third chapter formula as well as fourth chapter formula. I told you that all the chapters are interlinked. Here by the third chapter formula you have to find out mean. By the third chapter formula you have to find out mode, and by fourth chapter formula you have to find out the standard deviation. Okay, so here mean, mode and standard deviation. So chapter number 3 and 4 all are mixed here. Now only the formula is given here for Karl Pearson for the skewness as well as the coefficient of skewness. But for that you have to find out first mean, mode and standard deviation on the basis of here chapter number 3 as well as on the basis of chapter number 4. Okay, so here this is the formula. This is the simple formula when mode is defined. Here in this case, in both the formula you have to write down here, please write down, when mode is defined, then we have to use this formula. But if mode is, see, when the distribution has multiple modes, not one mode, different or multiple modes, okay, or when the values of mode is ill-defined, okay, the mode is obtained by the empirical formula. When mode is ill-defined, we have to use the empirical formula. See here, what is the empirical formula for mode? 3m minus 2x bar. This is the empirical formula for mode. When mode is ill-defined. Given by the Karl-Pearson, thus the skewness is obtaining the following formula. Skewness is equal to what? Again, formula for skewness is same, x bar minus MO. But here MO, that is mode, is ill-defined in this case. So we have to use the empirical formula at this point. So here you can write x bar minus 3m plus 2x bar, because the formula for x bar minus 3m minus 2x bar, right? So here what is the formula? Plus, so you can say here x bar minus 3m minus plus 2x bar. So you can say x bar plus 2x bar, that is 3x bar minus 3m, or you can say here make a common 3, then x bar minus m. So the skewness, ultimately the formula for skewness, if mode is ill-defined, formula for skewness if mode is ill-defined is 3 into bracket x bar minus m, that is median. If mode is defined, then you have to use just this formula. But in the case, in the sum, mode is ill-defined, then you have to use this formula. Sk is equal to 3 into bracket x bar minus m, that is mean minus median, into 3, that is your Sk, that is your skewness, and the coefficient of skewness, second, that is J is equal to, here again Sk upon S, but here Sk is equal to what? Coefficient formula is not changed, Sk upon S, but here the Sk is equal to 3 into bracket x bar minus m, that is x bar minus median upon standard deviation. So the formula for J when mode is ill-defined is 3 into bracket x bar minus m, that is mean minus median upon S. Okay, so here the formula, please write down these formulas. So there are, see here, skewness xk is equal to mean minus mode x bar minus mo, x bar minus 3m minus 2x bar, that is 3 into bracket x bar minus m, and coefficient of skewness again sk upon s, that is here sk is equal to 3 x bar minus m upon s. That is S means standard deviation. Okay, note there are two types of skewness. First is positive skewness and the second is negative skewness. Here, if the mode is well defined in a distribution, please note, read the note first. If the mode is well defined in the distribution, skewness is found out by this formula. If it is well defined, Sk is equal to x bar minus mo. For the positively skewness frequency distribution, x bar greater than mo, and thus the Sk is equal to x bar minus mo greater than 0. Hence, when Sk is greater than 0, the distribution is said to have positive skewness. See, when Sk is greater than 0, it is positive. And when Sk is less than 0, that is in minus, then it is called a negative. So the skewness, if we can say the skewness is positive or negative, whenever the skewness is greater than 0, then it is called a positive skewness. When the skewness, that is by the using formula of Karl-Pearson, if we find out the skewness, if the answer is positive, it's a positive skewness. If the answer is negative, it's a negative skewness. Very simple, right? Now the second point, if the mode is well defined in the distribution, skewness is found out by the formula Sk is equal to x bar minus Mo for negatively skewness, right? X bar less than Mo, that means here Sk less than 0. Okay, so answer, whenever that find out for skewness, if the answer is positive, that is greater than 0, it is a positive skewness, and when the answer is negative, then or it can say less than 0, then it is a negative skewness. Note, in practice, coefficient of skewness lies between -1 to 1. Coefficient of skewness for this. For coefficient of skewness, that is, it is lies between -1 less than or equal to j less than or equal to 1. So here, when in practice, coefficient of skewness is lies between -1 and 1. In always, whenever you are doing the sum of skewness by Karl Pearson method, your answer of J, that is coefficient of skewness, is always between -1 to 1. When the mode is defined, compulsory, when the mode is defined, your answer of J is equal to between -1 to 1. Second point, if the frequency curve of the population has multiple mode, that means here if the mode is ill-defined, then the formula for skewness J is equal to 3 into bracket x bar minus M upon S, and it is lies between -3 to 3. When mode is well defined and when mode is ill defined. See the answer, compulsory, your answer is between -1 to 1 when mode is defined. Whenever you are finding out by skewness and coefficient of skewness by this method, x bar minus Mo and x bar minus Mo upon S, your answer is compulsory between -1 to 1. If your answer is -2, if your answer is 1.5, then your answer is wrong. Compulsory, your answer is between -1 to 1. So -1 less than or equal to j less than or equal to 1. And if you are finding out the skewness by this method, that means if here the mode is ill-defined and you are using this formula to find out the coefficient of skewness, then your answer must be lies between -3 to 3. Okay, if your answer is 3.5 or if your answer is -3.9, then your answer is wrong. Compulsory, your answer is between -3 to +3. So this is the main point. Please remember that and please write these all these things. Whatever I am writing on the board, please write down these in your example book, because this is the formula and the important points. Important points what? Coefficient of skewness value compulsory lies between -1 to 1 when the mode is well defined, and it's lies between -3 to 3 when it is ill defined. Mode is ill defined. Third point, if the year 1951 statistician N.L. Johnson proved that the coefficient of skewness obtained as J is equal to x bar minus Mo upon S, that is the main formula, theoretically lies between √-3 and √3. That is, it is between, third point, -√3 less than or equal to j less than or equal to √3. That is -1.73 less than or equal to j less than or equal to 1.73 is the value. Okay, so here the formula as well as the curve is given here. First of all, please write down these and then we'll discuss the next example, that is illustration number 1. So first of all, write down these. Okay, now see the illustration number 1. The following data related to units transported by 50 trucks from railway yard to different factories on a day. Find the skewness and its coefficient of skewness using Carl Pearson's method from this data. Okay, so number of transported 120, 130, that is your X is given, and the number of trucks, that is your F, frequency is given. And it is which type of data? It is, first of all, you can say it's a discrete group data. And what we have to find out? Skewness as well as coefficient of skewness. And for that, here Carl Pearson method is we have to use, and this one is the Carl Pearson method. But we have to decide. See, in the question there is no any information regarding the formula. Just say the method. Carl Pearson method we have to use, and in the Carl Pearson method always there are two methods. Again, there are two methods. We can use this or we can use this. But for that we have to first of all find out the mode. If the mode is defined, then we have to use first formula, and if the mode is ill-defined, then we have to use this formula. So by seeing the question, see the highest frequency. First of all, what is the highest frequency in that? 11 is the highest frequency, and the respective observations of highest frequency is 160. So here you can say the mode is defined, so we can use this formula. Okay, whenever into the question there is no specification regarding the which formula we have to use, just only say the with the Carl Pearson method. See the last line of the question. Find the skewness and its coefficient of skewness using Carl Pearson method. Carl Pearson method we have to use, but in the Carl Pearson method two methods are there, and here mode is defined. That's why we have to use this formula. Okay, so now I am doing the sum. Please concentrate here. First of all, write down the question into your fair book, example book. Illustration number 1. Number of units transported X. Then frequency, number of trucks. That is your F. $120 3, 4, 5, 11, 9, 6 and 1. See, we have to find out the skewness. For that, the formula is Sk is equal to, here the mode is defined. First of all, we have to find out mode in the question of skewness. First, we have to find out the mode. Therefore, here I am writing MO, mode is equal to highest frequency observation. Therefore, MO is equal to, what is the highest frequency? Here the highest frequency is 11, and that's why the corresponding observation is 160. That's why you can see here mode is equal to 160. MO is equal to 160. Okay. So here the value of MO is defined. So Sk is equal to x bar minus MO. Here we have to find out the x bar. See, all the observation is more than 100. I told you at the time of third chapter, then whenever all the observations are more than 100, then you can use the shortcut method. It is very easy to find out the mean. So here I am using that formula, D is equal to x minus a upon c. That is the shortcut method. All the observations are above 100, and that's why I am using shortcut method. If all the observations are below 100, then we can use the direct method. Here it is very easy to calculate by the shortcut method mean. A is equal to what? Assume any amount from these. I am assuming 160. A is equal to 160. C is equal to, common 10 is there. So C is equal to 10. So you can say this one is the 120 minus 160 divided by 10. So 12 minus 16 minus 4. 13 minus 16 minus 3. 14 minus 16 minus 2. 15 minus 16 minus 1. 16 minus 16 0. 17 minus 16 1. 80 minus 16 2. 19 minus 60 3, and the 200 minus, that is 20 minus 60 4. Okay, so here your D is ready. Make the total first of all, and what is your N? N is equal to, find out, $50. N is equal to 50. Now FD, for mean we have to find out FD. This one, multiplication of these two. 2 into minus 4, minus 8, minus 9, again minus 8, minus 5, 0, 9 ones are 9, 9 twos are 18, 6 threes are 18, and 4 ones are 4. Sigma FD is equal to, find out the total. $19 is the total. Now X bar, yes, we can find out the X bar here. After that we can find out X bar. So here I am writing X bar is equal to A plus sigma FD upon N into C. Because we are taking C as a common from these, that's why we have to see. This formula is used in continuous group data, but here we are taking C as a common, that's why we have to multiply 8. Now put the value. A is equal to 160, sigma FD 19 divided by 50 into 10. So here is equal to 160 plus 19 divided by 5. 3.8. So x bar is equal to 163.8. The value of x bar is equal to 163.8. The value of mode is equal to 160. So you can say that Sk we can find out. Yes, Sk is equal to what? Sk is equal to x bar, that is 163.50 minus 160, and Sk is equal to 3.50. Skewness is equal to, but we have to find out the standard deviation compulsory, right? To find out the coefficient of skewness. The formula for coefficient of skewness is J is equal to coefficient of skewness. J is equal to x bar minus mode, mean minus mode upon S. So we have to find out first of all S. Okay. So here for S we have to find out FD square also. FD square means D into FD. F into D square. FD square means what? F into D square. So you can say FD into D. That is FD square. So multiplication of these two columns. 4 exa 32. 27 minus minus plus minus minus plus 8 2s are 16, 5 1s are 5, 0, 9 1s are 9, 18 2s are 36, 18 3s are 54 and 16. So sigma FD square is equal to, make the total, 195 is the total. Yes, you can say that 195 is the total. Okay, so what is the formula for standard deviation? S is equal to sigma FD square upon n minus sigma FD upon n whole square into C. Here I am finding out the standard deviation. Okay. First of all, we have to find out mode, then we have to find out mean, then SK, or you can say third one, you can find out third as a standard deviation, and then finally these two measurements. So here third one is the standard deviation, and then fourth SK, that is skewness, and the fifth, that is coefficient of skewness. Okay, so here we are finding out the standard deviation. Put the value here is equal to into square root sigma FD square, that is 195 upon 50 minus 19 upon 50 whole square into 10. After the square root, into 10. So into the square root, 39, that is 3.9, sorry, 39 minus 3.9, sorry, 3.9 minus 19 divided by 50, that is 3.8 all square, 39. Three 0.38 all square is equal to 0.38. 19 divided by 50, that is 0.38. Square of that is 0.14. 144 into 10. So 3.756 into 10 square root 1.93794 into 10. So the ultimately answer, therefore S is equal to 19.38. S is equal to 1.93794 into 10, that is 19.37, but 9 is here. That's why 19.38 is the answer of S. Okay, so S is equal to, here the value, first mode, that is 160, second X bar, that is 163.8, third standard deviation, that is 19.38 is here. Now SK, we have to find out the skewness as well as the coefficient of skewness. Fourth one, skewness is equal to X bar minus MO, 163.50 minus 160. So the skewness is equal to 3.8 units. Sorry, here 163.80 is there. So 3.80 units is the answer. And now absolute measure is over. Now relative measure, that is coefficient of skewness, we have to find out. J is equal to X bar minus MO upon S. That is X bar is equal to 163.80 minus MO is equal to 160 divided by S is equal to 19.38. So here you can say SK, that is 3.80 divided by 19.38. So J is equal to 0.1961, or approximate value, therefore J is equal to 0.20. See, it is lies between compulsory, always the value of J when mode is defined, always the value of J is lies between -1 to +1. So here 0.20 is between -1 to +1, and here you can write units, but this one, that is relative measure, is free of units. That's why we don't have to write anything here. J is equal to 0.20, nothing else. Okay, so here the last line for this answer is, thus the distribution has a positive skewness. The answer is positive, you can say positive skewness. The answer is negative, then you can say it's a negative skewness. Okay, so here you can write that this distribution has a positive skewness. It should be noted that J is equal to 0.20. It's free from units, as coefficient of skewness is free from units. That you can write or you cannot write. Okay, it's okay. But first of all, the last answer, that means here the answer is positive. Then you have to write down that the skewness is a positive skewness, nothing else. You have to write down that. Okay, so here illustration number 1 is over, and now time for homework. See in this 5.1, exercise 5.1, only one question you have to write in your homework. Exercise 5.1, question number 1 is your homework. Okay, so here I am complete my lecture, and we will discuss our next illustration and next topic in our next session. Till that, goodbye, have a nice day.